Up next, we are going to be covering one of the most confusing and important topics in computer science, recursion. Let's start with the most important question. What exactly does recursion mean? In programming, recursion refers to functions that repeatedly call themselves, meaning that in the instructions that occur within a function, one of the instructions will be a call to the same function you are already in. In the extremely primitive example on your screen now, you can see you have a function which calls itself. A recursive function will usually take into account some integer as an argument and will use this to carry out some instructions. Some instructions modifying the integer that was entered before calling itself again with that new integer as its argument. To better understand these functions, let's discuss the basics of how we go about programming one of these recursive functions and create one ourselves. A really good easy example of a recursive function is one which sums all numbers from 1 to n. So let's make a recursive function that does just that. The first thing we need is the actual function, and we are going to make it an integer function which takes in an integer called n as an argument. The reason we do this will be explained later, but for now let's move on to the base case. A base case is simply a definite value which all recursive statements, the ones that are being repeatedly called as we go through the function, try to get towards. At the beginning of the function we test the value that was passed in by the argument against the base case to see if it is satisfied. Usually these base cases are some requirements, like if n, as I described before, reaches a certain value or is equal to a certain value. It is extremely important that the base case is set to some requirement that n will eventually meet, for the same reason that it is important to avoid infinite loop. We don't want a Stack Overflow error to occur. For example, if our base case was to stop calling the recursive function when n was greater than 100, and if it is not, we call the function again, but with n minus 1, and we started with n as 99. We will never reach the base case, and the recursive function will repeatedly call itself over and over again, subtracting 1 from n and hoping that somehow it will eventually be greater than 100 until your computer crashes. So anyways, back to our recursive sum example. Let's make our base case when n is less than or equal to 1. This way we can start at some positive integer n and subtract it until it hits at or equal 1, in which case we can exit the recursive statement. Now if n is not less than or equal to 1, what we want to do is return the sum of both n and then the returning value of our recursive sum method minus 1. Why do we add n plus the function call? Well, let's actually go through the function as if we were the computer and see why. We start with a call of recursive sum with n equals 3. We know that 3 is not less than or equal to 1, so now we try to return a recursive sum of n, which is 3, and then returning value of recursive sum with n of 2. We don't know what the returning value of recursive sum of an n of 2 is, so we have to go through the function again, only this time n is 2. Again, n is not less than or equal to 1, and so this function will go into the else statement and return 2 plus another recursive statement, in this case the returning value of recursive sum with an n of 1. So once again we have to go through the recursive sum function to get the value that will be added to 2 and then returned and added to 3, then returned. Hanging there, we are close. Now in this function n is less than or equal to 1, so we return n, which is 1. Now we take that n, which is 1, and that is what gets added to 2 in the previous function call, then returned. So this will return 3. Now this 3 is what gets added to the first function call, which is 3, and so it becomes 3 plus 3, which is 6. And finally, after all the time, we get returned 6 from the function, which, if you have been following along at home, 3 plus 2 plus 1 is indeed 6. Now this may seem like a waste of time, since 1 plus 2 plus 3 is not a hard operation, but to those of saying that, I ask you to please give me the sum of all the numbers from 1 to 3567 in Godspeed. Now, recursions are a very difficult concept to wrap your head around, so if you are not 100% comfortable with it at the moment, please rewatch this lecture to better familiarize yourself with it. Alright, now that we have a little background on recursion, let's talk about why it works so well. Now, to understand why and how recursion works, we must first understand what a stack is. A stack is a data structure that contains all of the tasks you instruct your program to complete. Based on a certain method, your program will then carry out the task you give it. It's called a stack because if we call start another process before the previous one completes, the process is stacked on top of the other one, such as the animation on your screen. Programs we write will follow the LIFO structure. For those unfamiliar with accounting, LIFO means last in, first out, or the last item put on the stack will be the first one removed from it. Essentially, every time you ask your computer to complete a task, the task is added to the stack and be the first one to be resolved. Think of it like a stack of stones. You can keep adding stones on top of your pile, but in order to get one near the bottom, you first have to remove all the rocks on top of it. Now, when your function continually calls itself without end, without a base case, like in our infinite loop example, then the stack will never be resolved, as items will continually added to the stack without any of them ever being completed. In this case, the memory allocated to the stack is exceeded and a stack overflow error occurs, resulting in your program crashing. Think of this as if you are doing chores, and before you complete one chore, you get called to do another chore. And then, before you can complete that one, you get called to do another one. Since you keep stacking tasks or chores on top of each other, the stack of tasks will never be completed and you will probably die before ever finishing any of your chores. This is the same logic that makes infinite loops crash your program. Recursion works on these same principles. The initial call makes a second call, which is added to the stack, and now that one must be taken care of first, but in that another function is called, which gets added to the stack, and so on until you reach the base case, in which you slowly start to going back down the stack. In conclusion, recursion in general is extremely useful because by calling the same functions repeatedly, it breaks down the problem to smaller sections, results in the program being more efficient. Small parts of problems are easier to solve and less taxing to compute than the entire problem at once. The computer can combine these small solutions into the main solution in the end.